Hello everyone. So this week is going to be a week focusing on fractions. I'm actually not going to have a lot of lessons, so hopefully it won't be too overwhelming because I know fractions is kind of like a, just a really hard topic for a lot of students. Right, so we're going to be working with fractions that actually have variables in them now. This first one, we're just going to focus on simplifying. Okay, so simplifying rational expressions. Right, so fractions are just like a number over number. Rational expressions, right, we got that keyword expression in there. Remember, expressions can be like x plus 2, 2x minus 12, so on and so forth, right? Those are all expressions. So we're going to start dealing with fractions that have variables, expressions on top of them, right? So maybe like x over 5. Right, these are all rational expressions. Okay, we're not going to actually really get too deep into expressions like this. We're going to just kind of really focus on just getting used to fractions with variables in them. If you move on like to algebra 2, you will definitely see things like this a lot more, but for now we're just going to get the real basics of fractions now with variables inside of them. Okay. Okay, so first of all, simplifying, right? So simplifying fractions, simplifying ratios. If you remember how to do it with like numbers, right, what do we need to do if you just have two numbers? Right, we're going to try and find the greatest common factor between the top and the bottom, right? Find or numerator and denominator numbers. Okay, so 24 and 36. So if you think of what are all the possible factors of 24, 2 is 1, right? 3, 4, 6, 8, 10, 12. Right, those are all the factors of 24. How about 36? 2, 3, 4, 6. Can you do 8? I'm having a hard time remember that. 24, not 8, right? 9, 12, 18. So these are all the factors of 36. Right, the factors are just the numbers I can divide this number by or that number. And we want to find the greatest one. I mean, you can use smaller ones, but when you're trying to simplify something, you're trying to get it as simple as possible, which means like the smallest number. They don't have any common factors anymore. You've got this down as simple as you can make it. So that's why we want to go for the greatest common factor, right? Because they have 2 and 2. They both have 3. They both have 4, 6. They both have 12. But 12 is the greatest common factor. It's the factor that they share. That's the biggest number. Okay, so 12 is the one we're going for. Okay, so we have this fraction, 24 over 36. So some people simplify it two different ways. So if you think of, like, if I'm going to factor using the number 12, 24 is equal to 2 times 12, right? And 36 is equal to 3 times 12. Okay? And hopefully you remember when you multiply fractions, you're just multiplying the tops by the bottoms. So we could rewrite this like this. And so then if we look, what is 12 divided by 12? Right? If we have any kind of number over itself, 12 divided by itself, what does that give you? That just gives you 1, right? Same number on top and bottom. 12 divided by 12 gives me 1. So this technically is just 1. So 2/3 times 1 gives me 2/3. Right, so 24 over 36 is equal to 2/3. They are, it's a ratio, they are fractionally equivalent, you know, however you want to put it, but we simplified this fraction to this fraction. That is what simplifying is, and we did this by basically canceling out anything that can become 1. Okay, so that's, and of course I did this in super, like, all of the steps possible, but if you skip steps, that's totally fine. Some people like to do it this way, and I'm hoping this is all review, because there's no variables yet, right? Some people just do it kind of more in their head. So we know 12 is the greatest common factor, so we're going 24 divided by 12 gives me 2, 36 divided by 12 gives me 3, so I have 2 on the top, 3 in the bottom. So, you know, however way, if you like writing it all out like this way, go ahead. If you like kind of like crossing it out this way, you can do it either way that you prefer. You're doing the same thing, just one you're doing with more steps. And sometimes for some people they like writing all the steps. It helps them think through the concepts. Okay, so alright, so that's simplifying with just numbers. Okay, so now let's do this with variables. Okay, so let's say I have a, or 5 times a over 7 times a. Again, if we want to write this out, right, 5 times a, 5a is just 5 times a, right? And again, we have a over a. So remember, that thing you have to remember is that a is just a variable. It's just a variable we don't know. I mean, it's a number. We just don't know what it is yet, right? Sorry, it looks kind of like 9, but it's an a. Here, maybe that helps. Those like funky a's. Maybe I made it worse, I don't know. That's an a though. Okay, so 5 times a, 7 times a. A is just a number, and we have the same number over itself. And what is the same number over itself? 1, right? So we can actually cancel this out, and it just leaves us with 1. 5/7 times 1 is just 5/7. So you can see we actually just canceled those a's out. A over a is 1. We divided them out. I shouldn't say like canceled. We didn't make it like 0 or anything. We just know a divided by a number divided by itself, gives you 1. Okay, so now let's just do examples with more variables. Let's make it a little more complicated now. Putting some exponents in. Okay, we want to simplify this one. This time there's no number, just variables. So the way I like to think about this is to break it down into factors. Just like what we did here, I broke it down into factors. Just like what I did here, I broke it down into factors. So I'm going to break x cubed down into factors, which would be x times x times x, right? Because when you multiply them together, you get the cube. And then we get x over x. And something, just so you don't get confused, to remember, you can always multiply anything by 1, right? So there's always like a 1 there, just kind of invisible. We don't write it because why would you? That's that identity property. But the only reason why I want that is so people don't think it's over 0. Right, so x over x, right? Just like a over a, x over x is just going to be 1, right? X over x is just 1. And then there's no x down here, so we're still going to be left with this x. So we have x times 1, which is just x, over 1. Any number divided by 1 is just itself. Okay, so x cubed over x squared, we can simplify it to x because we're canceling out all of the common factors from the top and bottom. Okay, we'll do another one like this because I'm going to show you a shortcut after. so sometimes you start getting a lot, you know, big numbers for your exponents. So x to the 7th is x 7 times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, so I can cancel that out. That just gives me 1. That gives me 1. That gives me 1. That gives me 1. And I'm left with this. These can't cancel out. There's no more common factors on the bottom. So I'm left with x cubed. That's my answer. But I want you to notice the pattern here. 7 and 4. What happens if I go 7 minus 4? I get 3, right? How about if I have 3 minus 2? I get 1. There's always, technically, if there's no exponent, that means the exponent is 1, right? Because you're saying I have 1x. If you have 2, you're saying you have 2x's. 3 means 3, so on and so forth, right? Again, we don't write those ones because it's like everyone just assumes. We all know it's there. But 3 minus 2 gives us 1, so x to the first power is the same as x. 7 minus 4 is 3. Right, so there's a little handy rule. Sorry, that's an A. You can just subtract the exponents to get your answer. So whatever those exponents are. So let's do another one. So it's just a shortcut. If you don't want to do the shortcut, you don't have to. So using the shortcut, instead of me writing x 9 times in the top and then 5 times in the bottom, I can just go 9 minus 5, and then I get x to the 4th power. Okay. So what happens when you get a negative number when you subtract them? Right, so let's say we have this, right? And so if I were going to subtract this, I have a negative exponent, right? What does that mean? So we'll do this the long way just to show you what it means. This is another one where I want you to remember there's a 1 on top. Okay, so that cancels out, right? That cancels out. That cancels out. That cancels out. But now we're left with 2, but this time they're at the bottom of the fraction, right? And I'm left with the 1 on the top. So 1 over x squared. So what this is showing you is if you have a negative exponent, that means it's actually going to be a positive exponent, but on the bottom of a fraction. Okay? So you have a negative 1. Let's do another one with like small numbers or smaller. Right, if I were going to do 2 minus 4, I'd get negative 2 again, right? If I were going to write it out. Don't forget there's that 1. Or if you just remember these are all becoming 1s, right? Then you won't forget that there's a 1 on the top. Right, 1 over x squared. So if I were going to do it the shortcut way, 2 minus 4, negative 2. So to the negative power means 1 over x2, the positive of that, the opposite of this, right? So that's what it means when you get a negative exponent, okay? And then one more weird exponent rule. What happens if you get the same? So x to the 0. Whenever you get something to the 0 power, well, if you look, x to the 5th over x to the 5th, that's just the exact same number, right? That's just like having x over x, or a over a, or 12 over 12, 5 over 5, right? It's the same number over itself, what happens when you divide a number by itself? You get 1. So anytime you get a number to the 0 power, that automatically just means that number is 1. Okay, so anytime you come across that, they cancel out, right? If you're going to write it out. Right, these are all 1, just becomes 1, same number over itself, I mean. Okay, so these are all kind of like tricky exponent rules. So now let's just do some examples. Now we're going to throw in some numbers too, and then we'll also throw in like multiple variables. Okay, so. But it's actually really not too, once you understand like the exponent stuff, then it just becomes a simplifying problem. So the way I like to do it is I like to separate out my numbers and my variables. Right, and I'm just going to focus on simplifying this one first, and then I'll simplify that, and I'll multiply them back together. Okay, so 15 over 25, both of them have common factors of 5. Right, if I divide out 5, I get 3. Divide out 5, I get 5. Okay, and then x to the 8 over x squared becomes, if I do 8 minus 2, it's x to the 6th power. Right, so I get 3/5 times x to the 6th. You can always turn a number into a fraction like that. Right, and multiply tops. Multiply bottoms. 5 times 1 is 5. And I've got my answer. So I simplified this original fraction of 15x to the 8 over 25x squared to 3/5 x to the 6th power. Okay. How about if we have multiple variables? Okay, we're gonna do the same thing. And you know, maybe you don't even need to write this extra step like I do where you separate them out. You might be able to work just straight from this fraction, you know, right here. That's totally fine. Whatever works for you. 15 over 5 gives me 3, right? X to the 6th over x squared gives me x to the 4th. Y to 7th over y to the 4th gives me y to the 3rd. Oh, well, and I should take away those. All right, and I got my answer right here. Okay, hopefully that's not too bad. Okay, so now I'll do this one. So I'll do it without like writing out all the steps. So it's 6 and 9. We're gonna focus on simplifying that first because they have common factors, so we can simplify that. They both have a common factor of 3. If I divide 3 out of 6, I get 2. If I divide 3 out of 9, I get 3. Okay. X to the 9 over x to the 7th is going to give me, I'll just rewrite it, x squared. Y to the 2nd over y to the 5th. So this is the one where 2 minus 5 gives me negative 3, right? So if I have a negative exponent, that means it's going to be on the bottom. Okay, so we have our 2 in the top, 2x squared, 3y to the 3rd. And that is my answer. Okay. Right, so that is basically how you simplify fractions with variables and multiple variables. Really, the most important thing is just remembering these exponents. If you have to do it the long way, that's totally fine. If you can't remember like the shortcut, then you can totally write it all out. But yeah, otherwise now I will move on to multiplying.